Hi everyone, this is day 2. We ended here with our solving. I think I got cut off. Just make sure you are checking these problems to know they are correct in your calculator. All right, next we are moving on to our functions. So in this section reminder, we were following what they wanted us to do with the two functions and then seeing what their domains are. I like to start my original problem. This f of x would be a parabola, and therefore if it is a parabola, our domain would be all real numbers. For this one, it would be a line, and so my my domain would be all real numbers. So since they both have all real numbers, we know that's going to be part of our answers here in the domain. It says we're going to take the f of x and divide it by the g of x. So I'm taking that first function and dividing it by our second function. Now we have it written like this. We cannot cross-reduce anything. I can't reduce anything in general. So this right here is our first answer. And now for our domain, as I said, they both have all real numbers, so we know that's going to be part of our answer. They both have all real numbers. Now this one has something special on it. Whenever you have a fraction, remember we can't have a 0 on the bottom. We can't divide by 0. So we're looking at, well, what would cause a 0 at the bottom? Well, what would cause a 0 on the bottom is if x equaled -4. So we don't want that. So our domain is all real numbers, but the only thing it cannot be is x cannot be -4 because it would cause a 0 on the bottom. So this is our second answer right here. All right, our next one says we're going to take our two functions and we're going to subtract them. Do be careful because you're subtracting the entire function. So what that means is I'm going to take the f function. I am subtracting my g function. That 3 looks terrible. I'm subtracting the entire thing. So what that means is I need to take this negative and distribute it to all of that. So I'm going to have x squared minus 3 minus x minus 4. So that negative went to both of these. From here now we're going to write it in standard form. So I have x squared is going to go first, then that minus x, and then we need to combine like terms, so this is now going to be minus 7. I can't do anything else with this problem, so this is our new function after we subtract those. And then our domain, as I said, they're all reals, so for this one, we have all real numbers. There's nothing it cannot be because I don't have a fraction, so that is our answer. All right, going on to the next page. Again, we're doing more function stuff. Sorry, that's what we did in class today. All right, so next thing we did is composition of functions. So reminder, that's when we're putting a function into a function. I like to rewrite my problems when they're written like this. I like to rewrite it that what I really have here is g of x. Okay. And so this is kind of showing me with a picture now what I need to do. It's saying, hey, take this f function and plug it into my g function wherever I see an x. So instead of that x there, I now have 2x minus 7. And remember that original x, it was being squared, so now my f function needs to be squared. And then I have the rest of this function, so the minus 3. We already saw this on our solving page. This says I write it twice. And then again, you need to FOIL it. So reminder, you're multiplying our first outside, inside, last. Okay, so what I'm going to have here is I'm going to have 4x squared. Outside and inside are both going to be -14, which is altogether going to become -28. And then our last is 49. And then remember we had that minus 3 at the end here. Our last step is we're going to combine our like terms. Make sure we're writing this in standard form. So I'm going to have 4x squared minus 28x, and now I have plus 46. I'm going to bring this down right here because this should really go in front of our answer because this tells us what we did. So if we're writing their things in proper notation, which I hope you guys are, that would go in front. So this whole thing here is our answer. Okay. All right, this next one, again, we're going to rewrite it. This time our f is on the outside and our g is on the inside. It says this time, sorry, this whole thing is going in for this x right here. So I'm going to have -3, and instead of that x, we have our x plus 1. We also have that plus 2, so bring that down. So again, notice you're taking your function and you're just replacing this x with whatever this equation is. Then we're taking that negative 3, we are distributing it, and then we are combining like terms. So I have negative 3x minus 1. I can't take this problem any farther, so we're just going to bring down that notation. So we have proper function notation. So this whole thing here is our answer. All right, we have one more composition. Now this time we're plugging in a number. So these two we plugged in an equation, so we got out an answer. This one we're plugging in a number, so we're going to get out a number. So again, I'm going to rewrite this that we'd really have our f on the outside, our g is on the inside, and our negative 1 is on the very inside. So now we're going to work our way out. So it tells me I'm going to take negative 1 and plug it into my g function. So I'm going to have g of negative 1. So this time, every time I see an x in the g function, we're going to plug in negative 1. So I'm going to have negative 1 squared plus 3. Grab in our calculator if we need this. This is really 1 plus 3, which is 4. And then we're working our way outward. So I'm just going to take this 4 now, and we're going to plug it into the f function. So now we're going to have f of 4. So now I have my f function. Wherever I see an x, we're going to plug in 4. And we're getting out 15. Again, I'm going to write this in proper notation. Hey, we took our f function, we took our g function, we plugged in negative 1, and all together we got out 15. All right, that is composition of function. I'd really recommend kind of drawing not drawing pictures, but showing yourself with arrows on what way everything is going. All right, the next thing we did with functions was writing them as inverses. So the first thing we need to remember is to kind of help ourselves. I'm going to change this f of x to a y, and then remember the real thing that you're doing with inverses is you are switching your x and your y. So instead of a y here, I'm now going to have x equals, and we have the square root of y minus 2. Now it's kind of like how we did on our solving. I'm trying to get this equation to say y equals. So to get rid of a square root, I'm going to square both sides. So what I have now is x squared equals y minus 2. And then our last step is to get rid of this 2, so I'm going to add 2 to both sides. Now from here again, we're going to write this in function notation. So this is really now our inverse. So I'm going to rewrite that y and inverse of our function. It now equals x squared plus 2. And now again, this kind of goes back to our domain thing we did on the other page. This is really a parabola. So parabola looks like this. So a parabola is a function, because our x's don't repeat, or also how a lot of us know this, is it passes the vertical line test. I can pass a bunch of vertical lines through that, and it will only hit my graph once. Okay. All right, this next one, I'm going to put a star on this. Some people might want to study this one. Again, I'm changing this to a y. I'm flipping them because that's what makes it an inverse. And then again, we're solving for y. So the first thing I'm going to do is I'm going to subtract 4. So now that's an ugly 4, sorry guys. So I have x minus 4 equals y squared. To get rid of a square, we need a square root. And we already saw this. Whenever we square root things, we have two answers. We have a plus minus. I can't take this problem any farther, so we are going to write this in inverse notation. So I have the inverse of our function, and we have the plus minus of the square root of x minus 4. Now, because we have the plus minus, if I were to put a graph on this, reminder, we've done this in this chapter, a square root graph looks like this on the positive side, but on the negative side it looks like this. So this one, if I were to run a vertical line through this, it is going to fail. So this one is no, it is not a function. It fails VLT. Okay. All right, I'm going on to our last page. Our last page, we are graphing. We have our two different types of graphs, and we do both of these in two different ways. We are going to graph a parent graph and the transformed graph. When we are doing square root graphs, here are the numbers that you're always going to use for x. We're going to use 0, 1, 4, and 9. The reason why we're doing those, they are perfect squares. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. This one, I need to add in a third column because I have something in front of my root. So this tells us you're going to apply a negative to all of your y's. Now, luckily, 0 doesn't have such thing as a negative 0, so that stays as a 0. This is now going to be negative 1. This is now going to be negative 2, and this is now going to be a negative 3. I'm going to get rid of my old y's, and now this is my new parent graph. So the first thing we're going to do is we're going to graph our parent graph. 1, 2, 3, 4, 1, 2, and 9, 1, 2, 3. Okay. I am connecting them here, and our arrow only goes out. We don't draw an arrow over here because we cannot square root negatives. Now, looking at what we just did there and what we're about to do, so what we just did there is we just did an x-axis reflection. Okay, so that's why it's upside down now. And then I need you guys to notice we have a minus 2 here, so that means the next thing we're about to do is go right 2. And then the other thing we're going to do, that plus 3 at the end there, we're going to go up 3. I like to grab a different color just so I don't get confused. So now, oops, sorry, my thing is starting to freak out. I'm now going to take every single dot now, and I'm going to go right 2 and up 3. We're going to go right 2, up 3. Hopefully your guys' graph looks way better than mine. Right 2, up 3. Oh my gosh, this looks terrible. Sorry, guys. Okay, so hopefully you guys have a graph like this, and again, we connect it. Arrow goes this way. All right, now here's where our domain is a bit intense. This starting point here, because of the right 2 up 3, it is now at 2, 3. This point right here. So this kind of tells us everything about our domain and range. So all of our x's are going this way. So that means all of our x's are greater than 2. So we moved it 2, so that's why it's there. All of our y's, now all of our y's are going down because of this. So these are all going less than, and then again, they all start here at 3, and then they go down. All right, come back for part 3. Sorry this took so long. I'll finish the last 2 problems. All right, come back in a little bit.